This video lesson is intended to be a supplement to your textbook, so I'm assuming that you've read and are familiar with Modulo. There's a few things I'd like to point out that will be helpful, and one of those is just my expectations, and that's also just how it works in mathematics. If you're looking at 5, we say, well, that's equivalent to 2 when you're doing mod 3. One of the things that's a couple of things that are important when you're doing modulo is, at least when you get to the final answer, that you use the equivalent sign and not equals to. Because after all, 5 is not equal to 2. It's no way that that's true. But 5 is equivalent to 2 when you're doing mod 3. It would not be equivalent to 2 if you're doing mod 4. So two of the things that I expect to see when you're doing modulo is the equivalent sign, and at the very end, what mod you are doing. You don't have to do it during the work, but your final answer should at least appear like this. When you're doing modulo, there are different ways to do it. One quick way, students can pick which way they like to do. Some students simply do it in their head, but it's also possible to look at it and say, well, 11, doing mod 3, I'm going to think of it as a 3-hour clock. Every time I get to 3, I group everything in groups of 3. So 3, 6, 9 plus 2. Of course, we know the answer is going to be that it's equivalent to 2 when doing mod 3. But for some students, it's helpful to look at it and say, well, let's do each step. And one way of doing that is, for every time you see a 3, you just say, well, 3 is equivalent to 0. In a 3-hour clock, you go once around, you're back right where you started. So the 3's become 0, and everything else then, of course, you end up then in saying that's equivalent to 2. And again, when doing mod 3, it's the only way that it works. Some other students prefer to use the division algorithm, which is taking 11 and saying, well, I'm using a 3-hour clock. And how many times do I need to go around the clock? Well, 3 times. Gets me right back where I started. And 3 times 3 is 9. There's 2 remaining. And then saying, well, when I'm doing this, then this is equivalent to, well, 3 is the same thing as 0. You end up with a 3-hour clock, you end up right back where you started. So 3 times, or 0 times 3, plus 2. And of course, then that is equivalent to 0 plus 2. Which is equivalent to 2 when you're doing mod 3. Of course, again, the importance of making sure that you've got the mod and all of that kind of thing there along with it. Now, just a quick reminder on some of the shortcuts. We're going to end up working with another shortcut in a later lesson when you're doing modulo. But for now, there's 2 things that I'm hoping you remember. When you're doing a series of numbers like this, especially when you see the homework sheet, oftentimes it's easiest just to work this one particular one first until you get to an answer, and then work the next one, and it just makes the work a little bit easier. So, if we're working with 2 to the 4th, exponents we cannot touch with modulo. They have to stay there. But the number that you're raising to a power you can work with. Now 2, using mod 5, well, there's nothing you can do with that. So in this case, we just have to figure out 2 to the 4th is 2, 4, 8, 16. Well, 16, now again, here you can set this up any way you want. You could say, well, 16 is this 5 plus 5 plus 5 plus 1, and then of course they're all equivalent to zeros, so you end up with 1 when you're doing mod 5. Now, when you're doing something to a large power like this, obviously I don't expect you to be able to take 5 and raise it to the 301st power. It's a clue, first off, that there's a shortcut that you need to use, because your calculator, probably even your computer, won't calculate what 5 to the 301st power is. So, again, you have to leave the power alone. You can't do modulo to the 301, but can you do can you take 5 and do mod 5 to it? Well, sure you do. If you take 5 and excuse me, 5 and do mod 5 to it, well, there's only one 5 in it, and there's no remainder. So this becomes 0 to the 301st power. I just took a shortcut and explained it there. If you're not sure exactly how that works, just let me know. Well, 0 to any power is always going to be 0. So that makes that one rather simple, actually. Now, if we're doing 6, 5 plus 1 is 6, or 5 times 1 plus 1. So we know that if you take 6 and do mod 5 to it, you're going to get a remainder of 1. That is obviously going to be much easier to multiply. If we take the 31, we can say, well, 31 is equal to, it's a 5-hour clock, and we're going to go 6 times around, and so that's 30, plus 1 gives 31. And then, of course, this is equivalent to the 5-hour clock. You end up going around 6 times and ending up the same place, so that's equivalent to 0, plus 1. So we find, okay, well then this is equivalent to 1, and again, that's when we're doing mod 6. So, we can put this up here and get 1. Well, this makes this much easier. 1 times 1 is 1. 1 plus 0 plus 1 is, of course, 2. And so we're going to need to have a final answer again with the equivalent sign. 2 is the modulo, and remember the mod 5 as well. In a similar way, another shortcut that you will you can see and likely will see again shows up here. The excuse me, 8 to the 4 we can use a calculator and figure out, or actually multiply it out ourselves. But if we remember, again, that we can do modulo to whatever number is raised to a power, well, 5 is 1 time around the clock plus 3. So the remainder, oh, excuse me, we're doing mod 7 this time. So we're using a 7-hour clock. 8 to the 4th power, if you're doing 8 and doing mod 7 to it, the remainder is going to be 1. 7 times 1, 1 time around the clock, plus 1. So this becomes 1 to the 4th, which of course is 1. Now, if we do 15, again, I'm not figuring you're going to try and calculate this and then do modulo to it. So take 15, not the exponent, and do mod 7 to it. 15 is the same thing as 7 times 2 plus 1, or 7 plus 7 plus 1. So that becomes 1 to the 652. Of course, 1 raised to any power is always 1. So that made that one really simple. Now, for the remainder, when we're doing 10, do mod 7 to it, 1 time around the clock plus 3, or 7 times 1 plus 3, the remainder is going to be 3. As always, modulo, we're just interested in the remainder. And 48, if we say, well, if it was 49, that'd be nice and simple, it'd be 0, but it's 1 less than that. So 7 times 6 is 42, plus 6 at that point. Now we've got something we can work with. We can't do mod to either of these, so we multiply them together, and that, of course, becomes 18. So then we still have the 1 plus 1 plus, can we do mod 7? Oh, yes, of course we can. 7 times 2 is 14 plus 4. The remainder is 4. So we get that. 1 plus 1 plus 4. The remainder is 6 when we're doing mod 7. A common mistake students and that happens with students, is they say, okay, I did modulo here and I got 18, so the answer is 20. But of course, 20 you can do mod 7 to, and you would end up with 6 as a remainder. But by doing it here, it makes it easier as you go. If you have any questions, feel free to email me.